The curve C1 has equation y equals x squared times x plus 2. Find dy dx. Sketch C1, showing the coordinates of the points where C1 meets the x-axis. Find the gradient of C1 at each point where C1 meets the x-axis. The curve C2 has equation y equals x minus k squared plus times by x minus k plus 2. In the bracket where k is a constant and k is greater than 2. Sketch C2, showing the coordinates of the points where C2 meets the x and y axes. So I've got the problem here. Okay, so C1 is given by then this curve here. It's a cubic curve, so it's going to go up, down and up. Find dy dx. So let's do part A. So dy dx then. Well, I'm just going to expand this bracket first. It's going to be x cubed, and then it's 2 lots of x squared, isn't it? So differentiating that, the 3 comes down, use the power rule, 3x to the 1 less, which is 2, plus the 2 comes down to be with the 2, to make 4, x to the 1 less, which is 1, so it's 3x squared plus 4x. Sketch C1, showing coordinates where C1 meets the axes. So part B then. So we've got y equals, what did we have? Let's just get it from above. X squared times x plus 2. Okay, so we need to paste in an axis. Let's paste one in, like so. Put it over here. Okay, so let's have a look at this then. We want to sketch it as a cubic curve. It's going to come down from above because it's plus x cubed, isn't it, here? So we're going to come down, turn probably, and go back down like so. This is 0 when x is minus 2. And it's also 0 when x is 0, isn't it? So y equals 0 when this is 0. And as we said, that implies that x equals 0. And also when it's minus 2, which we've marked in here. Dy dx equals 0. So it's 3x squared. Let's take an x out as common. So it's 3x plus the 4 equals 0. Implies x is 0, isn't it? And also when minus 4/3, which is just after minus 1, isn't it? Back this way here. So basically it has to come down here, so it's going to turn here, so that's going to be a minimum. This has to be a maximum, it's going to turn and go back down. So I've got a digital pen, so I'm going to use dashed lines. It's going to turn here, go back up to a maximum, and then turn back down and go back down like so. And this is our curve, y equals x cubed plus 2x squared, x cubed plus 2x squared. So that's what we've got then. So that's part B. What else did it ask for in part B? Sketch showing coordinates where it meets the x-axis, which we've done. So this coordinate here is 0, 0. This coordinate here is minus 2, 0. So those are the coordinates in question. Okay, that's part B then. Find the gradient of C1 at each point where C1 meets the axes. So we need dy dx, don't we? Where C1 meets the axes. This is part C. At x equals 0, y dashed equals. Here's dy dx at x equals 0, y dashed is 0. And at x equals minus 2 then, y dashed equals. Put minus 2 in here for y dashed. Minus 2 squared is 4. 3 4s are 12. Minus 2 in here. 4 minus 2 is a minus 8. 12 minus 8 is 4. So that's the value there, and this is the 0 here. So that's part C. Find the gradient of C1 at each point where C1 meets the axes. That would be the x-axis, wouldn't it? X-axis. C2 has equation this. Now if you'll notice, it's very similar to this equation here in form. Instead of x we got x minus k, instead of x we got x minus k here, all the way through basically. So sketch C2 showing coordinates where C2 meets the axis. So I'm going to sketch it on the same graph because I've got a digital pen. So part D now, I'm going to use a different colour. So I'm going to use a green, and I'm going to sketch it. So y equals, what was it, x minus k squared, x minus k plus 2, and k is bigger than 2. Okay, so let's have a look at this then. So it's going to be the same as this. It's going to be a shift, isn't it? Now, when in the x values, because when x is k, we'll get the naught value here. So this value that occurs when x is naught for the original graph, which is here, occurs when x is k, isn't it? And this will be naught again. So the k is bigger than 2, so it's as though that one moves over to here. And this is a value k. And this value must shift over 2 as well. So shifted over 2, but k is bigger than 2. Shifted over k. K is bigger than 2, so it will shift over here, won't it? Because k has to be bigger than 2. So what value is this? Well, the root it will shift k units. So it's k minus 2, because both of them shift forwards k. So it's the same graph, so I'm going to draw it in green. And apologies that I've used the same sketch, but it's simply because it must turn exactly the same. It's only a shift, and then it comes down here, doesn't it? Like so. Apologies for the same graph, but I have got a digital pen, so it's a good excuse. But in an exam you would certainly draw it on a fresh sketch, of course. So, now we need to indicate where it crosses the axes. It crosses the axes here, both axes. This would be at k and 0. This point here would be k minus 2 and 0. And then this next point here, well, when does it equal 0? When does y equal 0? When does x equal 0, rather? Well, x equals 0. We get y equals. Put 0 in here. Minus k squared is k squared. And put 0 in here, we get 2 minus k, don't we? So this is k squared, 2 minus k. So there's our points on the 3 points in question on the axes.